Hello, everyone. Today we are going to be factoring trinomials. Now, we might need a quick refresher on that, right? If something is a trinomial, it simply just means means there are three terms. So most of the problems that we're going to work with today are going to kind of look like what's at the top of the page, number one. When we say trinomial, it's going to be something in the form of like with something simple. We're only going to be working with one specific variable. And it's always going to be in descending order. So it's going to be the squared term, the x term, and then the number without a variable. So all polynomials that are set up this way can actually be potentially factored more than just finding that GCF. So before we get going, we are going to start off with just a little bit of vocab for today. And the first word that we're going to talk about is something called a quadratic equation. So what exactly is a quadratic equation? Well, a quadratic equation is simply just a polynomial that has a degree of 2. So for example, the one that we looked at up here, that is your typical example of degree 2. If the highest exponent that's somewhere in that problem tells you what the degree is, which would be 2. So specifically, when we look at those quadratic equations, the method that we use to factor this is called the grouping method. All right. So factoring by grouping, all it means to factor by grouping is it's just a way of factoring trinomials. There's a lot of different methods out there. There's obviously the greatest common factor method, which is actually a part of this method. So that's always why we factor by greatest common factor first. Now, kind of like I mentioned, this method we really only use with polynomials that look like this. So like, for example, if it was an x squared plus 5x minus 6, something where you have a number times x squared plus or minus another number times another x, and then a plain old number on the end. So these problems always have at least an x squared in them. Now, this is kind of how it's going to work. So first I thought before we get into the actual factoring, I want you guys to think about multiplying a special type of polynomial together. And let's say we take a binomial times a binomial. So something that looks like this. So back in the good old days when we factored recently, we're going to go through and we're going to factor this. We're going to multiply these together. So multiplying is a lot easier than factoring because it just involves us going through and obviously multiplying every term in the first polynomial by every term in the second. So when I do that, x times 5 becomes 5x. If I fill in all of my boxes like this and we add our like terms, our simplified answer to this would be x squared 5x minus 4x. That's going to turn out to be a positive 1x. And then minus 20. Now, if you were to do it to all the other ones, this is what you get. So if you look at everything that gets end up factored, when you multiply everything out, you actually get a lot of problems that look similar. Now, if you look at any of the problems that I gave you, you're going to notice that all I really did with all of these polynomials was I kept the same number, but I changed all the signs. So if you were to do box method and multiply everything out, these are what you'd get. And you're going to notice that you actually get a lot of polynomials that look really similar. No matter which problem you end up doing, they all end up kind of similar to the one that we did first. You multiply them out, you're going to get a 4 by 4 box, and then we always are going to be able to add the middle terms. The difference is that the signs kind of change what everything is going to be. So here it could be you're taking a 5x plus 4x, or when you do negative 4 times 5, you get negative 20. If you change the signs, it changes what you get for the middle answer for anything that's in all the middle of these, or it changes the numbers that you get on the end. And in a pretty similar fashion. If we think about it, to get this 20 right here, all we did was we took negative 4 times 5, which where we took the numbers and multiplied them together. To get our middle term, we added these guys together, in which case we took negative 4 plus 5, and that became the number in front of x. So the idea is that what we're going to be doing today is reversing this process. So if my goal is here today, I'm going to be giving you this problem. And your job is going to be to move it back and make it into something that looks like this. So there has to be kind of a way for us to undo that process. So this is the method that we do, and it's called grouping. So what it does is it kind of attempts to undo that process. If we look the numbers that go in those second spots, they have to multiply together to give you the number that's on the end. But they have to add to end up being that number in the middle. So that's kind of where factor by grouping starts. Now you guys can cross off down below where it says guess and check. Cross that off. That's another method that you can use to factor, which I might show you guys later, but we're not going to do that today. So factor by grouping, this is how it works. Our first step is we multiply what's called A times C together. And all we mean by A and C, it just means the number that's in front of the x squared and the number that's on the end. A lot of times we'll call that number in front of x A, the number in front of the middle term B, and the number on the end C. So our first step is to take our A times our C, so 1 times 12. And that's the number that we're going to look to try and make things multiply to be. So we have to ask ourselves kind of two questions. We have to say what two numbers end up multiplying to be 12. But if I take those same numbers, oopsie, that's not what I want. I'm sorry, guys. Struggle. What two numbers multiply to end up being 12? And what two numbers add to give us whatever our middle term is, which in this case is 7. This is the first question that we have to answer. Now, you're probably asking yourself, well, Ms. Hardy, which one do we start with first? Now, there is one that's always easier, and it's always the multiplying. So our first step is we have to figure out, okay, well, what numbers multiplied to give me 12? And we just did this in GCF. If I divide by all of my numbers, 12 divided by 1 is 12, 12 divided by 2 is 6, 12 divided by 3 is 4, and we can't go anymore. If we make our factor list, these are the only nice numbers in the world that multiply to give me 12. But how do we choose which of these options are going to be the correct one? Well, we want to also look at answering the second question. What two numbers also add to give me 7? Well, if I look, 1 times 12 is 12, but 1 plus 12 is 13. Now, we could be dealing with different signs, but for these, since everything's positive, I don't care about any negative pieces. So that tells me it's not going to be 1 and 12. 2 and 6, if I add those guys together, yeah, they multiply to give me 12, but if I add them, they give me 8. That's not 7. So that's not going to be our answer. And the winning combo is 3 and 4. If I take 3 times 4, we get 12. And if I take 3 plus 4, we get 7. So 3 and 4 are going to be our, what I usually call them is the magic numbers. Because what those end up being, those are the numbers that should have been in the diagonals in the first place. So what we do with that is we actually use it to replace whatever the middle term is. I'm going to break up 7x into its parts. How we got to 7x was we added 3x and 4x together. So the first term, how the second step goes, the first step stays, or the first number stays the same. This is what we call the rewrite step. That middle term, we're just going to start by rewriting as whatever our magic term, or whatever our magic numbers were. And here's where factor by grouping gets its name. We're almost at our final answer. Really, what we have to do is we are going to actually factor by grouping. We are going to group because I now have even terms. So I'm going to group my first two terms together. I'm going to group my second two terms together. And basically what we're going to do, we're going to kind of treat them like separate problems for just a moment. We're going to go ahead and we're going to find our GCF of each of these problems. So my first term, we have an x squared and a 3x. The largest number that goes into both of those is 1. The largest amount of variables we can take out, well, the first term has 2x's, my second term has 1x, which means I'm going to take 1x out of both of these. So GCF goes outside. All of our remainders are going to go back on the inside. X squared, if I had 2, I took 1x out. We're left with 1x. 3 divided by 1 is going to be 3. And we took the x's out because they divided each other out. And we do the same thing with our second polynomial. Now here, they don't have any variables in common because 12 doesn't have any variables, but 4 is the largest number that divides both of those guys. If you needed to make a factor list of those guys, you could, like saying 1 times 4, 2 times 2, but the largest number that ends up being in both of your lists ends up being 4. So that's how I know what number it is we're going to divide by. So I'm going to divide both of these guys by 4. GCF goes on the outside, leftovers go back inside. 4 divided by 4 is 1, it cancels. Bring down our x. And 12 divided by 4 is 3. Now, you'll probably get to this stuff and you're like, Ms. Hardy, I see something that's similar about them. So once we actually group and factor them, the awesome part about this is now these two pieces of the problem, they're always going to have something in common. And that is this part right here. What this tells you is we now know what our final answer should be. The common factor that they have, that whatever in the parentheses, that is actually one of the factors. And the other factor is going to be what is on the outside. So this 1x and this 4, together those create our second polynomial. And that is our final factored form. Now, nothing changes about what we did the other day. You'll notice that if there was a GCF to take out in the beginning, we would have. In this case, fun fact, it was 1, which is why I didn't do it on this one. But sometimes we deal with some more complicated ones here too. So let's go through and let's do one more. So how we always start, and this is going to be on the second page, example, not B. I'm going to go to the next page. Example C, we're going to start by taking our A times C. So take the number in front, which is 1. I'm going to multiply it by the number on the end, which is 16. And that's the number that we're going to use. We're going to ask ourselves really the question, what times what gives me that number? And what plus what same numbers, if I add them, add to give me my middle term. So the 16, that's just A times C. The negative 10 is just the number that was in the middle up here. All right. So we have to now answer that question. So what we're going to do now is we're going to look at 16. And 16, we're going to find all of our factors. 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, and we're done. Now here's where we have to be a little bit careful because we have to add to be a negative number, which means we have to kind of be careful about signs. In the signs world, if I am multiplying things together, there's kind of like 3 cases of things that can happen. If I multiply 2 positives together, if I multiply a positive times a negative, or if I multiply 2 negatives together. And either way, no matter which way I go, positive times a positive is always going to be a positive answer. If I take a positive times a negative, we get a negative answer. And a negative times a negative is always going to be a positive. So that's something to kind of keep in mind. If I'm saying, well, what multiplies to be a positive 16, that tells me something about my signs. That means I can either have 2 positives or I can have 2 negatives. And if our sum has to be negative, that just means that all my signs have to be negative. Now, same thing, we're going to say, well, all of these numbers multiply to give me a positive 16. What adds to give me negative 10? Well, only one of them does. If I take negative 2 plus negative 8, that gets me negative 10. And negative 2 times negative 8 gives me a positive 16. So negative 2x and negative 8x, these are our middle numbers. I'm not going to circle it because, again, not our final answer, but we are going to use it to go ahead and factor. We keep the first term, keep the last term. Those become my middle terms. And now we group and go. So that's what I want you guys to try. I want you to find the GCF of each of these guys, factor it out, and I want you to see if you can tell me what our final two quantities would be. Pause your video now and go. All right, you should have had this as not your final answer. I stopped halfway. But if you took your GCF out, the first two terms, you should have had a GCF of X. And my second term, be careful not to drop that negative. Technically, this acts like a leading negative in this case, because it's kind of like a separate problem, right? And whenever we start a problem with a negative, that always comes out. Now, how you know you did it correctly, this is what's nice about grouping, is that these quantities should always match. If they don't, that means you made a mistake, because one of those factors, whatever shows up twice, that ends up being one of your factors. And whatever your GCFs were ends up being your final answer. Now, if you really wanted to, you could, if you wanted to check your answer and box them out, you could. If you wanted to check to see if you have your final answer correct, well, let's multiply them back together. X minus 2 times x minus 8. Well, x times x is x squared. X times negative 2 is negative 2x. Negative 8 times x is negative 8x. And negative 2 times negative 8 ends up being positive 16, which if I add my middle terms together, negative 8 minus 2 ends up being our negative 10x plus 16. And that was the problem that we started with, which means that this is our final answer. All right. So that's factoring. If you want to give some of these others a shot, we're going to do some in class together. But if you're feeling good, you can go ahead and you can start working on the practice for today.